You open a SQL Server database, hundreds of tables, no documentation. You click around, open a few tables, look at column names, and very quickly you realize you are not understanding anything at all. And then someone casually says, "Hey, don't worry, it's simple." Yeah, sure. Because right now, it doesn't feel simple at all. You don't know what the key tables are. You don't know things are connected. You don't even know where to start from. And that feeling, if you have worked on a real project, you already had it. This situation happens all the time. You join a new project, you inherit a legacy system, you start an audit or migration, and there is no documentation. Or even worse, there is documentation, but it's completely outdated. So you try to understand the system, open some tables, you stare at some columns, you guess relationship, and that's the problem. Because if you guess and you guess wrong, you can build completely wrong data sets without even noticing, which is honestly the most dangerous type of bug. So instead of guessing, figuring out, let's do something smarter. In this video, I will show you how to reconstruct a full data model using only SQL Server metadata. No assumption, no reverse engineering in your head, no manual diagram, just fact. And step by step, we will go to clarity from confusion. Or maybe that's the other way around, you know. It's better from confusion to clarity. Before we start, one quick prerequisite. SQL Server features depend on the database compatibility level. We will use some query like string aggregate within group order by to reconstruct order keys and join condition. So I need to make sure the database compatibility level supports that. Because nothing says fun audit like a syntax error. 5 minutes into the video. So let's make a quick look. So let me zoom on it. So we will check the versioning of the table and of the database, and we will check the compatibility level. So let's just do that quickly. Versioning. SQL Server version. And then DB name. As current database. Let's check on that. As you can see for the current database, we have version 2025 and 15. But let's also check the compatibility level. And this one is going to be hard. Maybe should zoom a little bit. Thanks. Name compatibility level. This database where name equals DB name. So we have the compatibility level at 170, which is fine for us. In case you are not in the right compatibility, you can do something like this. You just need to make an alter table, but for this case, alter database, and you set. So for here, it would be wide world reporter, which can be found here. And you just need to set it at 170. The first thing I do is simple. I check the scope. How many tables? How many views? Because it's changed the strategy immediately. If there are 20 tables, you can explore them manually. And if there are 300, 400 tables, you need a method. And views are also interesting. Sometimes they simplify the models. Sometimes they hide the complexity. At this stage, I'm not looking for details. I'm calibrating expectation. So let's try this query. You can see there's not a lot of table and not a lot of view to be provided. Next steps, columns. It looks trivial, but it's very informative. Columns are complex proxy for complexity. A database with a few hundred tables, usually manageable. A database with several thousand, it actually means more business logic, more transformation, and more edge case. And probably more surprise waiting for you. So here we have 1,889 tables. Just to give you some information, all queries will be available for you to use and try them. We're not trying to reconstruct everything from scratch, since these are really informative videos. Now we zoom in which tables are the widest. These tables are very important because wide tables tends to be central business logics, staging layers, or legacy tables that kept evolving over time. You often see new columns added, old columns never removed. And gradually you end up with something quite dense. Well, if you see a table with 120, 150, or 200 tables, that's not just a table. It's an history book. And in this case, we're pretty safe. There's not a lot of table with large amount of columns. Now, let's look at the volume. But where is data? Because in real system, not all tables matters equally. The biggest table usually contains transactions, events, logs, or history. And those are critical not only for understanding the model, but also for understanding where performance issue will appear. One quick note, this is an approximation, but for an audit, it's more than enough to prioritize. So here we can see it's usually order lines, invoice, archive tables, transaction tables. Now we ask a fundamental question. Do we actually have a data model, or is it just a collection of tables? Primary keys define identity. Foreign keys define relationships. If both are present, you have a good structure. Well, good is a word really great. If not, well, you have something more, let's just say, creative. And in that case, everything will become harder. Join, integrity, and understanding. So let's check if we have keys here. That's good. We have 36 primaries and 89 foreign keys. But here is the catch. Just because foreign keys exist doesn't mean they are reliable. If they are disabled, they are not enforced. If they are not trusted, SQL Server can't guarantee the data respects them everywhere. So you have rules, but they are not guaranteed, which is like having speed limit with no police. So you can see here, no foreign key, disabled, not trusted, and all the keys are correctly and used as primary cases. Now we get strategic. We don't want to analyze everything. We want an entry point. And the best entry point is the most connected tables. Because these tables either references many other or reference everywhere. They sit at the center of the models, understand them, and suddenly everything else starts to make sense. They are basically the influencer of the model, but at least they work. So you can see these tables are quite interesting for us to check first. And especially the people one and the customer one. At this point, I don't just want a structure. I want meaning. So let's use an heuristic way to guess table rows with three hypotheses. Big tables with many outgoing links are often look like fact. Tables reference a lot often look like dimension, and small isolated tables often look like reference or lookup. But it's not perfect, obviously, but in a real project, it's a great compass. And honestly, it's always better than most documentation. Let's try this. There is a lot of mixed tables, but it's for archive, customer transaction, it's still being used. But everything here is likely. And you can see that you have a lot of unknown tables. So, no surprise, let's use Copilot GitHub for this thing. That's the first for me. So I don't know how things will be going. So, you are a senior engineer. So let me rewrite it, copy paste. But let me show you clearly What the hell is going on? I think I need to zoom in. So you are a senior data consultant using only the table stat below, row count, foreign key, in and out, and table type guess. We need to validate or challenge the guess. If you disagree with the query, explain why. Propose a candidate star schema. List likely fact tables and the likely dimension tables. And let's give an onboarding path. The first 5 tables to inspect in and in what orders. List like risk, red flags, hubs, missing key, suspicion pattern. But we only use the information provided. We will not invent tables or columns. And everything uncertain, let's make it as assumption. So it's only past the 20 rows here. Let's move it. Copy and that. And let's go. Yeah, it's in French, so try this. So course archive table for cold room temperature is a fact table. Stock is confirm, like confirm. It's quite interesting because it's able to figure out what we're not sure of tables. And of course, vehicle temperature is a fact table. Orders, we don't know for now. Invoice, same. We don't know for now. It's not it's more like a bridge table. It's not pure fact table like what we are expected in a star schema. People, customer, of course, are dimension and references. And they also are able to provide you a guess on primary schema and candidate scarce schema with fact tables and dim tables with multiple guesses. And of course, onboarding pass trying first, second. So we can start with people, customers, stock is them, maybe. And what could be the risk? There's some table without foreign key, courtroom, vehicle temperature, and some table without in foreign key, like customer transaction. And also some table we're not aware. Single entity with multiple rows. This is something that use a lot of in our table. Say table. And we'll not cross all the issue we have spotted, but it's great to read all this, and we'll not deep dive into the queries. Quick recap first. A primary key defines identity. It guarantees each row is unique, whereas a foreign key defines relationship. It links one table to another. So, in very simple terms, primary key, what something is. Foreign key, what it is linked to. And once you accept that, you stop thinking in tables. You start thinking in graph. Now we start rebuilding. Step 1, nodes. In other words, entities. Well, each table represents something, and the primary key defines its identity. Here's a trick. We don't join a pre-compute list. We will use an auto-apply here. Think of this as, for each table, run a small query that searches the primary key index and aggregate the key columns. So here you have the aggregate. Right. And you also have the key columns is outside of here. Let me check a few seconds. Which is here. And the reason it's outer is important. It behaves like a left join. So if a table has no primary key, we still keep the table in the output. PK column is just gonna be null. Well, a table without a primary key is like a meeting without decision. You can spend hour and hour and hour, and nothing is unique. Like this. You can see all the archive tables are most likely without primary key defined, and you can see all the other table with a spotted primary key. Now that we have a structure, but documentation is usually the missing piece. So here I export the tables, columns, metadata as a JSON. And I will ask Copilot to generate a clean data dictionary. Important. Copilot is not inventing the schema. It's summarizing what we provided and label assumption. So first, let's make a run on it. So here you have the JSON schema. Oh, great looking. And now we'll use again GitHub Copilot. So let's make here. So let's write it before we start making it. We are documenting an SQL database. Using only the JSON metadata below, let's create a dictionary. For each table, wildline, purpose, guess, key columns, and a confidence score based on 1 to 5. And for each columns, a short description guess based on the name and data type. And also, as usual, uncertain guesses will be marked as assumption. No invention and cautious language. And let's provide all this. Okay, let's go. Hopefully there's enough place. And we'll be right back. Welcome back again. So we have a lot of information. I think for each schema, it's able to deep dive each table and each column afterwards. So you will have a lot of information provided based on every table, purpose key, you have a description, and for every tables provided in the documentation, you can see information based on the UI login access, external authentication, and all the type of the columns. Basically, we will not be looking at all that, but it's really impressive. And hopefully help work better ways now. Step 2, edges relationship. Well, foreign keys tell us exactly how the tables are linked. So instead of guessing joins, we extract them precisely, which means we now know how data actually flows. No more, I think this is joined on that column's famous last words. Try this one. You can see at one scale, all table from this table to application cities to application people, and you can get all queries provided by foreign keys. So you can see here you can have the 98 because you have 98 keys earlier. Now we go level deeper. We follow relationships recursively, tables to tables to tables. And something very interesting happens. At sometimes you stop seeing individual tables and you start seeing structure, a hierarchy, a graph, a model. And this is actually the moment where everything clicked together. Well, of course, without the anti-cycle, put it here, you can loop forever, like certain meetings that never ends. So here you can see all phrase, indentation, step by step. And let's focus, you can see all level 1, level 2, level 3. And step by step from step 1, for example, you have April application cities, which goes to application state province. And from state province, you go to countries and so on, so on, so on. And if you want to go further and further and further, you can reconstruct the full path. Complete navigation routes between tables. Not just it's linked to that, but how am I going from Paris to Marseille? Step by step, joint by joint. It's incredibly powerful for debugging, impact analysis, and understanding pipelines. This is the GPS turn by turn. Yes, it can be intimidating, but that's normal. Let's try this. You remember before for the level, the columns, and the number of tables, and the foreign key? Now you have the whole structure from roots, final foreign key, tables, and you have all the paths being available. So if I choose, let's choose a big one. For example, if I choose from the warehouse stock item transaction. So let's move down here. You can see all the steps from the warehouse stock item. It goes to stock item. It goes to supplier purchasing, application cities, state provided, countries, and people linked. And the join path is all the queries linked together. Warehouse stock item transaction stock item ID will go with the stock item. Then the stock item will go to the purchasing supplier with supplier ID, and so on, which is quite an impressive tool. Up to this point, we have done reverse engineering. SQL Server gave us. Fact. The entities, the keys, and the exact relationship between the joint condition and behind each foreign keys. Now comes the part that usually takes hours in real project, making the model communicable. Because a list of foreign keys is accurate, but it's not something a stakeholder or even a new data engineer can digest quickly. So here I use Copilot inside the SSMS as a communication accelerator, not to discover anything, but to translate technical edges into an executive-friendly stories. Well, before we can see backup from the node tables, the edge table, my bad, and in the tree tables, and here's the result we saw earlier. And I passed it a small control extract, well, just between 10 to 30 edges and some branch, and I asked Copilot this. Cluster the model into a few domains, identify the most central tables based on relationships, and provide a simple onboarding path. I'll let you check the queries after, but this is what is required here. Rule of the game, Copilot must use only what we pasted. No invented object. If something is uncertain, this must be flagged as assumption. Basically, turning database archaeology into something that doesn't require a 10 hours meeting. And here, let's just not forget that we only apply on the people, application, cities, country, development, and we can see that there's a lot of information we provided. That all the core tables for each domain, in case you want to make schema by domain. The most central tables, which moves link and why it's central, and a description on them. A recommend on both paths in case a new data engineer arrive, a new business arrive, and you already understand where to look at first to understand the databases. And also all the business processes which allow us to understand more about data again. And I let you read all the note about architecture. So let's step back a little bit. You start with nothing. No documentation, no diagram, just table. But by using only metadata, you reconstruct entities, relationship, hierarchy, and full paths. Not by guessing, but by reading what SQL Server already knows. So less meeting, less confusion, and more truth. Maybe we'll think about it, but maybe there will be an episode 2 on how to infer relationships where foreign key doesn't exist. I let you on that. Please take care and stay safe.